In this video, I'm doing another volume problem using cylindrical shells. So we want to use cylindrical shells to find the volume of a solid obtained by rotating the region bounded by the function g of y equals 4 square root of y, and on the left by the y-axis for y being greater than or equal to 0, less than or equal to 5, about the line x equals -6. So what can be confusing about this problem is that some of this information is given to you in terms of y's, and then you have the line x equals -6. So it's going to be very important to determine whether you are going to be integrating this with respect to x or with respect to y. So first, let's draw ourselves a little picture. So we have our function, and there's my y-axis, and there's my x-axis. And the function itself, if you use Desmos to find it, is going to look something like this. And that would be my function g of y. And we're bounding it on the left by the y-axis, so that is going to be right here. And between y equals 0 and 5. These are my bounds on the y-axis. So we've got 0 being the x-axis, and 5. We'll put 5 right up here. So that is the equation of y equals 5. And so this is the region that I want to rotate about the line x equals -6. So let's put the line x equals -6 over here. Okay, so this is x equals -6. And let's draw ourselves a representative rectangle. And this will help you to determine whether you are integrating with respect to x or with respect to y. So my little rectangle, because remember the rectangle has to be parallel to the axis of rotation, and we have a vertical axis of rotation. So I'm going to make a vertical rectangle in here. And the width of that rectangle is along the x-axis, delta x. So that means that I am going to integrate with respect to x. So that means my formula will be the volume is 2 pi, the integral from a to b of x times f of x dx with respect to x. So everything needs to be in terms of the variable x. Well, let's see. We know what the bounds are. The bounds are going to be along the x-axis. And so the x equals 0 is going to be our lower bound. That's going to be right here. And so we need to know where these two graphs meet right there to find what this bound on the x-axis is going to be. So you can use Desmos to do that, or you can simply set the two equations equal to each other. But what we want to do first of all is take this equation and solve it for y so that it's in terms of x. So we have right now x is equal to the 4 square root of y, or x divided by 4 is the square root of y. And then squaring both sides, we have x squared over 16 equals y. All right, so that is the equation of this. And we want to know where that is going to be equal to y equals 5. So if I set this equal to y equals 5. Let's see, that's going to be x squared is equal to 80, or x is going to be equal to the square root of 80, plus or minus, but we can disregard the negative. And so x is going to be equal to 4 times 20, or 16 times 5, or 4 radical 5. So that would be our bound. So we have 4 radical 5 is our other bound on the x-axis. All right, so we know our bounds. The next thing we need to do is determine the radius. So remember that the radius is this distance from the axis of rotation to our representative rectangle. Well, this little distance in here from the x-axis to the rectangle is simply x. This distance right here is a distance of 6. And so this entire distance would be x plus 6. So that is going to be the radius of our cylindrical shell. So let's put that down. We have a radius now of x plus 6. And then we need to find the height of the rectangle. So the height of the rectangle, I'll do that purple, is here's the rectangle. The top of the rectangle is at y equals 5. The bottom of the rectangle is at the function, which is now x squared divided by 16. So the height of the rectangle is going to be the top minus the bottom, which is x squared over 16. So we now have everything that we need to put together our integral. So we have the volume is equal to 2 pi times the integral from 0 to, I believe that was 4 radical 5. And then we have the radius, which is x plus 6, and the height of the rectangle, which is 5 minus 1/16 x squared, all in brackets dx. We want to make sure that we use proper notation here. All right, before we can actually integrate this, now we want to simplify. Just do a little bit of algebra on it. And so we have x times 5 is 5x. We have x times a negative 1/16 x squared would be negative 1/16 x cubed. And then we have the inside terms would be 30. And then the last term in each would be 6 times 1 over 16. And so that is minus 6/16 x squared. Now, we can integrate. So we have the volume is equal to 2 pi. Finding the antiderivative of each term, we're going to have 5 halves x squared minus, so we're going to have here, what, 1 over 64 x to 4th plus 30x. And then minus 6/16 times a 1/3 is going to be minus 1/8 x squared. All of that being evaluated from 0 to 4 radical 5. Well, the rest of it you can do in Desmos. So you're going to have your capital F of x is going to be equal to 2 pi times the 5 halves x squared minus 1 over 64 x to the 4th plus 30x minus 1/8 x squared. And then you're going to find f of 4 radical 5 minus f of 0. And I don't know what that comes out to, but you can just do that in Desmos, and that will give you your final answer. So the key points of this video is how to set up a problem that looks like this, which by reading it can be a little bit confusing. Again, an important aspect of this is making sure that you know whether you are integrating with respect to X or with respect to Y. Another confusing thing about this is that it gives you the function as a function of Y, but you need to change that into a function of X in order to integrate it with respect to X. All right, hope this was helpful.